This is House Planning Help, episode 328. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Martin Twamley, Technical Director of Steico UK, and we're going to be looking at insulating internally with natural fibre insulation. Now, have you ever remembered a small act that someone has done for you? It could be something rather mundane, but something that has brightened up your day. I'll give you a couple of examples. Maybe it's as simple as a stranger saying something nice to you, or someone opening a door. That kind of thing. Well, I wanted to share one with you from a local building site. They're putting in a new housing estate like they do everywhere. Stationed at the entrance of this one, it's the role that you would bring in the lorries, tell them where to go and so forth, is a guy named Clinton. This is on a site near me. And he has started this thing that he's waved at everyone. I say started, he's been doing this for some time. So he'll wave, he'll smile. And at first, when it happens to you, you think, oh, that guy just waved to me. And then you start doing it, you know he's there, you know his name, and you wave back. And this has all gone on for 18 months or so until he's been moved to a different site. And then you go past and you wave and there's nobody there. But the funny thing was I went past the other day and they'd put a cardboard cutout of Clinton at the gate because so many people are still waving. So we can wave at the cardboard cutout now. How's that? You see, your actions do make a difference. Let's get to our featured interview with Martin Twamley, Technical Director of Steico UK. We're going to be exploring an internal wall insulation system that uses wood fibreboard. They're lovely materials. In fact, just before I recorded this interview, I was having a wander around their meeting room there and looking at some of the samples of the natural insulations and joining them all together. And it's just nice to touch, isn't it? So I thought that would be a good starting point for our conversation today, finding out a bit more about the company itself.
Steico have been producing timber-based materials since, I would say, the early 60s, and predominantly selling structural timber, insulation materials, most typically in Central Europe, that sort of area, and it's all sustainably sourced natural materials for structural or insulation materials. So it's a relatively small material base because it's all just pine or spruce, but they do make quite a lot of different products, so it can be quite difficult to sort of find your way through which products are used for which applications. So that's a lot of what we do really, is just trying to get people aware of what they use and where they should use it.
And how have some of these products developed? We come across them a lot in low energy building, I-joists, wood fibre insulation boards. I'm sure we're going to be talking a lot about these, but I'd just be interested to know where they've come from. Do they have a lot of processing in creating these items?
Not really. I mean, they have a low embodied energy. They're predominantly used in areas where people have an affinity with timber. So that's where they all started. So the big timber insulation companies like Pavatex or Gutex or Steico are all in that Central European, Germany, Switzerland, Northern Italy, Austria, in that sort of area, where they've got a lot of trees and they are used to using timber products. And it's spread from there, really. And I think once people start using timber and understanding it, it's a sort of material that you fall in love with and you then change your building process.
So is it a natural evolution to end up with engineered timber I-joists, for example? You know, who first started using them?
I think it is inevitable. That's probably more in recent years where we're thinking about climate change and the impact of the materials we use. That is where it really comes to the fore. They've been using I-joists for structural in America for much longer than we have. And that wasn't born out of sustainability issues. That was because for a certain structural application, they're the most sensible use of raw material. So there's a reason for doing it, but now that reason has almost come full circle, and it's not just about actually it's the right product for the right application. It's also the product which has the lowest embodied energy and stores the most carbon and uses the least carbon in its production.
What are the range then of these engineered products? Can it be categorized into a handful, or does it just go on and on?
No, the structural products are quite easy. So the I-joist and solid section material, which is the LVL, And the eye joists are made out of LVL as well, so the top and bottom flange is LVL, and the web material is hardboard.
Remind me what that means. It's
Laminated veneer lumber. So it's a material that's essentially to 3mm veneer of the tree. So we peel the tree, create 3mm veneers, bond them back together. And that way you take all of the weaknesses out of the timber and you spread that through the whole product, which means strength to weight ratio on engineered timber is much bigger than it is for solid section standard timber, which means you're getting a much stronger product for less raw material. And that's really what it's all about. It's optimizing, it's important to be using timber, but you've got to be using it in the right way and not over specifying.
And I interrupted you. Did you get to the end of the list of products?
Well, on the structural side, yes, because they're quite straightforward. So Steico joist, Steico LVL. On the insulation side, then it becomes a little bit more complicated.
But it's all the same source material, just bonded in different ways together. And what are you using? How is it bonded?
It's essentially like a WBP plywood. It's an external plywood, the bonding for the LVL veneers. But the good thing about the fact that we make the structural products and the insulation products is that we pretty much use 100% of the raw material. So what we can't use for structural timber, we can use for insulation. What we can't use for insulation, we produce our own pallets. And then if we can't use it for pallets, then we also have a biomass power station as well, and we use it for electricity generation. And all of that full circle and usage of material means that you are getting the best value for money from the tree itself. And that's a really important part of the process.
Okay, just tell me if I've got this all wrong. So you start by slicing it all up and then you're catching bits that are coming off. And
it's chippings. For the structural timber, you're debarking and you're peeling. For the insulation materials, there's a chipping process and a milling process. They're slightly different processes. And the more you mill the material, then depending on what stage you take it out of the milling process, you can then use it for... So the most basic wood fibre insulation is our Steico Zell. It's an air-injected wood fibre. And that's essentially a chipped tree, which is milled to a certain level and done.
And when it comes back together again, how long are these processes taking of you've got your chipped timber and now you're putting it into the product? Is it very quick or does it take weeks?
It is very quick. I mean, stuff will go through and come out of the machine a couple of days later, and if not quicker. Probably the longest part of the production time is the curing process at the end of the structural materials, because you have to soak the logs as well before you can peel them. So they have to go into a heat tank, and they'll sit there for a couple of days, softening, and then you can peel. So they're the bits at the beginning of the chain which maybe take a little bit longer. But once you've peeled or once you've milled, it's really quick.
Now, I've been to a cutting facility where I've seen all this stored. So when it's shipped, you can have quite long amounts of timber, eye joists, for example.
Yeah, so 13 metres is our standard length, but we do anything from 9, 10s, 11s, 12s, 13s. But you can have pretty much any length you want if you order a minimum for 5 packs. So if you want a 5.5, you can have a 5.5, 5-pack minimum order quantity. And then obviously, just all shipped in on Arctic loads, 12, 13 packs a load.
I'll probably have more questions as we go through this, but I did drag you here today to have a chat about internal insulation. So this is obviously a solution that you guys have come up with. So what has been your experience, first of all, of internal insulation? And that could be anything, not necessarily talking about wood fibre, but just the journey.
The requirement really for internal insulation depends a lot on what your housing stock looks like. So if you build really efficiently and you've got a load of really well-designed and specified and well-performing buildings, your need for internal insulation decreases. Unfortunately, we don't really have that in the UK. And we've also got the oldest housing stock in Europe. So we've got a huge volume of properties which need internal insulation for exactly that reason. And that has traditionally been done, I would say, in a way that potentially adds risk to the fabric of the building, adds potential for mould or condensation, and typically uses systems which try to block moisture rather than to be able to control it. And when you're trying to block moisture, if there's an issue with how that works, you have the potential for moisture getting into the fabric of a building. And that can be a problem for the timbers in a building, it can be a problem for the brickwork in a building. And so what we try to do is to create a system that can allow water vapour in, control it, hold it, and let it out again. So you're reducing the risk by using a material that can absorb moisture, hold it, and evaporate it. And that's what typically wood fibre does over the more conventional systems that are used, like, for example, dot and dab plasterboards or things like that.
Yeah, let's dig into dot and dab first. I know that this is not what you do, but just so we can really understand how that mould and so forth starts to come about. So is this a solution, in inverted commas, that others propose, and where does it start to go wrong?
The sort of standard systems that have been used for a long time will be file-backed PIR or PUR, polyurethane type insulation materials, which are either on a frame system or they are dot and dabbed onto brickwork. And by definition, those insulations are vapor closed. So in theory, they don't let any moisture through. And for the fabric, that's a good thing, because it's saying, okay, if there's no moisture getting in, I'm not increasing risk. It can lead to quite high moisture levels internally. So typically, you might need to think about MVHR systems or some way of reducing that high humidity level internally. But what can happen, and it's typical because a calculated system is very rarely the same as an installed system, because it's all about the quality of the way things are put in. And that, for us as manufacturers, that's quite difficult to oversee. So if those systems are used and warm air gets behind the plasterboard, you then have warm air hitting cold wall surface and an airspace. And that is an area where condensation can form. That is where an area that condensation and liquid water can gather, run down the face of the wall and collect. And that's the real issue, that if the system doesn't work as it should, you're creating a cavity, warm air, cold surface, condensing water, collected water, and that long-term water in the fabric creates mold and condensation issues.
Also, that don't get seen until sometime.
Exactly.
This could be years, couldn't it, until it gets through?
Absolutely, and I think that those are the issues that, because we've been doing that for now, and then people think, well, why am I only seeing it years later, is because it takes a long time for that mould to then show itself on the internal surface. It's not uncommon, and we've had some terrible stories in the press recently, haven't we, about rented properties or where there's just such real issues with mould, condensation, and the related health issues with that. I mean, the UK has the highest asthma rates in Europe, and there's a reason for that. It's to do with the air quality that we breathe. And when people think about air quality, they generally think about external air, but we spend 90% of our time indoors. It's the internal air that we're breathing. So that's what's impacting on our health. And that's why we really need to make sure that internal air quality is much higher than it traditionally is. And that's not an easy thing to deal with, because there's so many different factors to consider.
I think that's why on this podcast we always, although we're focusing on an internal insulation today, we always say about a whole house approach, that you've got to have a strong plan that includes things like ventilation, moisture management, all of these sorts of things. So for someone who sells insulation, is that almost a bit of a challenge, that do you know that the rest of the stuff is going to be done properly?
Yes, it is difficult because there are so many different systems available for people to choose from. And the most standard materials you can buy are those ones which you can get from a B&Q or a Jewson's or wherever, and you go and pick up the materials, and they will typically be petrochemical-based closed cell materials. And that's what 95% of tradesmen, that will be the first thing they pick up, and that's what they use. It's not until you delve deeper into the whole sort of holistic approach of how you should manage all of those issues that you start to think, well, actually, your material choice is actually really quite important. It shouldn't be the first thing at hand. You should be looking for a material that actually deals with all of the issues at hand. And typically, people use a petrochemical because the only thing they're thinking about is thermal performance during the winter. When people think, okay, I want to put some internal insulation on, their first thought is, why am I doing it? I want to keep my building warm. So that's the primary driver. But of course, it has other implications. Internal air quality, building fabric, moisture, all of those things need to be thrown into the pot as well. And it's only when you look at all of them that you can then make a more informed decision about the type of material you're using.
So take us through your wood fibre approach to internal insulation. And we've talked about the risk quite a bit already. You're mentioning a thin layer, aren't you? How do you define that?
I would say a thin layer is typically a layer that doesn't really impact on the internal room size, because if you're putting an internal insulation on, you want it to work. You want to create more warmth internally, but you don't really want to lose much room space. Not every house can afford to lose 100 mil off each wall interior, especially if it's on an external corner, or then, you can lose significant space. So you really want to try and say, okay, there's like an optimum amount. And typically for us, that's around about 40 to 60 millimeters. That's a layer which most rooms, even relatively small rooms, if you lose that sort of distance, you don't really notice it. And you're also getting around about 80 to 90% of your potential thermal savings from that thin layer. Every project is different, and that's why they all need to be assessed in a slightly different way. But that sort of thickness will work for 90% of properties. And that's why that's the standard solution that we recommend to people.
So solid wall properties, let's say someone's got a period property. Can you take us through how it would be applied, how you maybe even assess it first of all?
Assessment is really important, because what might work for one building won't work for every building, and what might work for one elevation of one building might not be suitable for another elevation of another building, or of the same building. So a west elevation or a north-facing elevation have totally different weathering exposure. One has a load of rain, much more sun, one is cooler all the time, and so if you're really assessing those through some sort of hygrothermal modelling, like a WUFI calculation or something like that, then you might say, okay, well, on one elevation I can use a 40 mil, and on the other elevation I can use 100 mil. But of course, most people will think, well, I just want to use one thickness everywhere. Generally, a 40 or a 60 mil on that sort of 215 mil standard brick will work in the majority of situations, because the amount of insulation ensures that the condensation risk is kept to a minimum. The thicker you go, the more critical it becomes. So if people really want to drive to that sort of really low U value, then independent analysis is really important. But our installation detail will pretty much just show 40 mil and 60 mil. There's a recommendation for the type of plasters and finishes you can use, but typically we'd say if you want to get the best bang for your buck and the best return for investment, just stick to those thicknesses. It's the simplicity of the approach that sometimes gets missed. And I know we've had a lot of information recently as well from the government about trying to come up with some new processes for insulating existing buildings. And they typically look at loft insulation and cavity wall insulation. But 70 to 80%, I think they say, of existing buildings have had that work done. And only about 5% have had internal wall insulation. And that's because people think, well, internal wall insulation is, oh, that's a lot to think about. I'd rather, if I do my loft and if I get the cavity filled, then actually that's enough. We really need to address all of those other issues, and internal wall insulation is the critical one.
How do we prepare a wall then that we're going to be bonding to?
In theory, you should be trying to have the wall system as breathable as possible. Now, that typically means you don't want anything on the internal side which hinders water vapor movement. So impermeable layers, cement-based plasters or renders, and paint layers. So in a perfect world, you take it back to the bare brickwork. What's really important as well is the external face, because the external face, most people think if I put internal insulation, I don't really need to worry about my external surface, but the external surface is where the majority of the water is coming from, because the water absorption coefficient of your external surface governs how much water is stored within the fabric of the wall itself. So an external render, a lime render, or repointing, all of those things need to be considered on the external side as well as what you're putting on the internal side. But the main difference between, I suppose, a natural breathable approach as opposed to a traditional dot and dab approach is that you don't have that cavity. So you have a full bonding layer between the insulation layer and the wall. And that ensures that any water vapor that's migrating through the fabric, it can't collect. So there's no potential surface for the moisture gets kept within the material and gets either passed on to the brickwork and out the front, or it can go back to the inside. It's that breathability aspect, and the fact that no cavity means no collection of liquid water, which is what really leads to the mould and condensation issue.
So at the end of this, when you've done this well, you've got a fabric that's working together, allowing the moisture to go through. So what have we done to make sure that happens? For example, you've got the little screw things on the inside that I'm assuming are thermally broken and so forth. So tell us about that. And then you've got the lime-based products in the middle, and how would you address getting back to that brick as well? So a few questions in there.
Yeah, I mean, it's The detailing catalogue will tell you the types of materials and the fixing processes, but you're really ensuring that you're using materials which can absorb and evaporate moisture, which allow moisture to be passed through them. So the insulation materials, for example, in conjunction with limes or clays, do that process really well. But the fixing process, the mechanical fixings that you use as well, you need to make sure they're thermally efficient, that you get the correct bonding between layers. And that whole process, the finished system, means that, almost to go right back to the beginning again, if you've got an uninsulated 215mm brick, and that wall has been absorbing moisture and typically it would have been heated internally, so there had been a lot of warm air going into that, moisture moving through it. So that's been going through those processes. Once you add an insulation layer and you potentially increase the internal moisture, you're increasing the moisture load with higher temperatures. So you're ensuring that the wall continues to do what it's always done, what it's used to doing, what it can cope with. The minute you try and say, I want to block the moisture, and that's simply what people think, I don't want moisture movement, I want to block it out. You're changing how that wall has been acting for 30, 40, 50, 100 years. And that could be problematic. Really, you want to keep the processes the same, but with higher moisture load.
Can any builder do this, or are we demanding quite a bit of attention again, and where do we have to be careful?
I think it's not straightforward because it's not as easy to get hold of wood fibre materials. So that needs, I would say, a bit of pre-planning, but that's really where we sort of step in and say, look, there's installation detailing, we can tell people where to buy the materials, and if they have any questions about calculations or modelling, we can show them where to go. We do a lot of work with the ASBP and the Natural Fibre Group, and the sort of education that they go through with podcasts, with webinars, is all about just making people aware that these products are out there. They are able to cope with a lot of the issues that other materials can't. And it's just awareness. It's raising awareness of materials. And I suppose that's a difficult thing, because you've got to reach quite a way into the market. You've got to try and reach the end user. And that's quite a long way away from where we as product manufacturers sit.
When we're installing in a nice, easy spot in the middle of a wall, that's fine. But what about the trickier areas? Can you identify a few of those?
Yes,
and what we do?
Yeah, critical areas, so reveals around windows. If you are insulating the wall, you've got a nice warm wall surface. Your coldest area is then your window reveal. If you don't insulate into the reveal, that's where all your condensation will form. Even though we say a 40 to 60 mil on the main wall, you obviously can't return a 40 or 60 mil board into the reveal, because otherwise you need to make a structural change in your windows. So you just return around the wall with a 20 mil board, and that's simple. Most window reveals can cope with 20 mil. It doesn't impact on the window, and it keeps the wall much warmer. So the reveals are really important. Critical areas as well are potentially, if somebody's insulating ground floor and first floor, they might not think about the void where the floor joists connect into the wall. And that is a really critical area, because you then have a real cold spot, and the condensation will be much more of an issue at the joist ends than it was before. So you really need to expose them either from above or below, insulate between, but more importantly, tape around the junction of the joist to the existing wall, so that there's no route for convected airflow into the wall where the joist ends are, because convected air holds so much more moisture. So airtight sealing around floor joists, for example, is really important. So those sorts of areas. Another one that springs to mind is where you have an internal wall connecting to the external wall. So if I'm insulating the external wall, the very corner of that internal wall, the junction, becomes quite cold. So I might need to insulate a certain amount of that internal wall, 100 mil, 200 mil, 300 mil of it. And we do products for that area. So there's a product that's like a Steico Tri, it's called, which is like a wedge, which you put in the corner and ensures that you don't then get condensation risk on the corner. It's not always required. It's really just in critical areas. But it's something that can be investigated with each property. And there's various areas, so they're in our detailing catalogue, that show this is how you should deal with that area, because sometimes the main area of the wall is pretty straightforward. I've got a run of insulation, I've got mechanical fixings, woomph, done. But when I get to a window, when I get to a door and a corner, what do I do? So the details are the important bit, really.
You've mentioned that you cover a lot of the technical requirements with documentation and so forth, but what do you propose when it comes to things like windows? If we're doing internal wall insulation, it might be part of something bigger, a whole house retrofit. So do you have any guidance on that, or are you passing on to someone else or trusting the architects?
Well, we have guidance on the type of board to be used, reveals how it should be fixed and what products should be used. Again, it does depend on what else might potentially be happening to the building. There are a lot of non-Steico related documents and brochures around for retrofit stuff. So there's one document in particular that is called the Guide for Sustainable Renovation. It's been put together by John Gilbert Architects and the Pebble Trust. You can download it from the Pebble Trust website. It's like the Bible of renovation systems. So it was predominantly based on build methods for old buildings in Scotland, but to be honest, can be applied pretty much everywhere. You know, in any sort of presentation I do as well, I'll always reference that at the end, because it's a really good resource for saying, if you're looking at a retrofit situation, what do I do in the loft? What do I do on a wall? What do I do on a floor? How do I deal with those different areas? And it has associated detailing, and it also shows what may have been done previously. So this is how these sorts of situations may have been done historically. And when I say historically, I mean the last 20, 30, 40 years. And maybe that wasn't the best approach. And these are the reasons why. And maybe we should be doing it this way. And then it gives you a way of doing it with different materials, with a more holistic approach, considering all of the moisture risks involved. So that's a really good resource for people. So I'd always sort of point people there as well.
So most of the people that come to you, are they professionals who are doing things like John Gilbert Architects? They've done retrofits, they're retrofitting schools and so forth. They've got experience. Or are you getting some self-builders who are thinking, I'm going to try and do some insulation at home? You know, I would always prefer the first category.
Well, we get a bit of everything, to be honest. So, you know, we have architects who'll just contact us out of the blue and just say, oh, look, I've got a job to do. My client has said they want to use a natural material. I've Googled it and I found you and I found Pavatex or I found whoever. And then they've got in contact and we'll talk about what the options are. Or it's a homeowner got in touch direct. You know, we've got a link on the website which allows people to send an email in direct, and they'll just be asking a question about what can I do. Other times people said, I've bought this material and I'm using it, and I've got to this stage, what do I do next? And that's the first point where we get any input. And, you know, to some extent you think, well, that's not great. I'd rather be involved at the very beginning, so I'm making sure people are doing it right. But there's nothing stopping people going out and buying material and doing what they want with it, as long as they're confident in the way they're doing it. And if they get to a point and think, well, I'm not sure, I maybe should have done this, or I should be doing it slightly differently, for them to get in touch and ask the question. And then we can say, well, yeah, you should do this, or maybe you should have done it slightly differently, this way or that way. And we get those we get emails come in every day of the week asking those sorts of similar questions. Although I would say the majority comes from architects, specifiers.
Is there anything else that we should know about that we haven't talked about in relation to this insulation solution?
I think one of the things that never really gets considered is the carbon storage element of materials. So a lot of time people talk about using materials which have a low global warming potential, so a natural material rather than a petrochemical based material, but they don't even ever consider the amount of biogenic carbon that's locked up in the product itself. I saw an article only last week in Bavaria in Germany. They have a new system local government has brought in that says if you are doing a loft extension or you're doing any sort of insulation on a property, you will get a €500 grant for every cubic metre of biogenic carbon locked up within the fabric of the building. And that's just fantastic. That shows you that local government and the relevant people are looking at that and thinking, actually, if we use materials that store carbon, we're removing carbon from the atmosphere, we're storing it in the fabric of the building, and that has a value. And we worked out a small example based on that. It was a little loft extension with a pent roof, and you could have got it around about €15,000 grant using timber and wood fibre insulations. And your options for that in the UK, zero. Not even considered. And it's not even on the radar. I suppose that's what I find quite frustrating, is that in the UK we are product agnostic. It is very much, if you achieve this performance level, I don't care what you use to get there. it shouldn't be that way. But I can't really see it ever changing because it depends what your drivers are. And the driver, I think, at the moment in the UK is to get to a performance level. Whether the building actually performs to that level at the end is another question entirely, but you'd be purely driven by performance. So if I can calculate...
And sometimes not even that. Sometimes how much money can we make?
Yeah, well, exactly. But, I've got to be a little bit careful about these things. So, but we've got a target U value typically, a target for embodied energy or GWP or whatever it is, but nothing actually looks at the amount of carbon stored within the fabric or the type of material that is used. And that can be quite frustrating. 10 years ago or so, I went to a presentation, I think it was the BRE had put together a new facility up in, I want to say Swindon, called the Hive. I don't even know if it's still there. The idea was that they would test various different building materials. And their plan was to test new, innovative materials. And I thought, well, this is a good idea. So we went along. It was opened by Duke of Wessex, I think, at the time, wherever that was. And they listed the types of new innovative materials they were going to test. And it was lime, clay, straw, wood. And I just thought, those are the oldest building materials known to man. We were using those for hundreds of years, thousands of years, with no issue. We were told suddenly, actually, it's much better to use high embodied energy, steels, petrochemicals, all of those, concrete, cement. And that's quite recent. Suddenly someone said, actually, they're them. And now we've got to the point to, well, actually, no, we were doing it right to start with. We might not been using those materials as efficiently as we can now, but now, with engineered timber, with new processes, we can use those same raw materials, use them much more efficiently, and actually go back to a much more natural and sustainable way of construction, which we should have always been doing.
Yeah, I think we just need more examples of this working, because even from my own self-build journey, I know that I ummed and erred about, for example, building with straw and didn't do that. But part of that was just the worry. It's not what everyone else is doing. And when it comes to selling all of these sorts of things, ensuring, it's just a mixture of...
It is.
It's in the head, I think, mainly.
We're quite traditional in that way in the UK, and not traditional in a good way, but in a bad way. We do it that way, and we think it works, so that's the way we do it. And that is driven a lot of the time, again, then by warranty providers and insurance providers who, by definition, are risk averse. And if they don't know a system, or if it's new, they say, well, then I don't really want to know and I won't give you a warranty. And that straight away, the seeds of doubt. If you go to a warranty provider and they say, oh, if you're using that natural material, I won't do that, I can say, okay, well, I know one that does. But even if the customer is then thinking, well, why don't they? Is there something I should know that is maybe a risk or I shouldn't be doing? And the minute you've got an element of doubt in a customer's mind, it's very difficult to take it away again. It's not until you've convinced them potentially to go down the route and they've finished and they're in the building and they're living in it and they say, I made the right decision. But that's quite a long way down the line. And it takes, people need to be invested and be happy with the approach they're taking.
So maybe finally then, have you got an example that we can share in the show notes of someone who's gone down this route and really, wants to shout about it, a case study?
I think so. I mean, we're showing at Future Build in March, and we've got 3 speakers, all of which are using engineered timber and wood fibre materials in varying types of developments. And all of those people have looked at the products. They're thinking, okay, the environmental impact, they want to use the right materials, but they're also doing it because they can do it cost effectively. And I think there's a perception that, well, look, if I go down the naturals route and then it becomes complicated, it becomes expensive, and maybe the client has got the money, but actually you can build that way, get much more efficient performing buildings, and actually price per square metre can be pretty much the same. So I'm hopeful that when those people stand and talk to people who are visiting Future Build, they'll be able to give them some examples of the systems and approaches that they're using, why they're doing it, the real drivers for them, not just ethically, but also financially, to say that actually we can build at scale with natural materials and it works, it makes sense. And the important thing is, at the end of the day, we will end up with a building which is working exactly as it says it should work. So it's highly thermally efficient, it's got good internal air quality, it's got really low energy bills, it's healthy climate, and all of those things added in. And that's something that the homeowner really appreciates and understands once they're in.
Well, Martin, really interesting today. Lots of good information. Thank you very much.
Yeah, you're welcome. It's been a pleasure. Thank you.
Head online to take a look at the show notes that accompany this episode, houseplanninghelp.com/328. We got a summary of the conversation. Also, if you'd like to comment on anything or ask a question, you can do that within the show notes. Just head down to the bottom or on social media. We will provide links and, of course, a link to Steico where you can find Martin as well. Once again, houseplanninghelp.com/328. My call to action is to check out the Hub, and this is the membership community that we run alongside House Planning Help, aiming to simplify the self-build journey, just take you through the process a few times. We have these in-depth video case studies, and I wanted to highlight one of them, the Buckinghamshire Passive House case study. It's a complete one, and this is where we follow entire builds, looking at decisions that are being made so that you can understand what you're going to need to do. And I mentioned this one because they use I-joists from Steico as part of the kit, the PH15 kit. And you see this whole process. So you can see how engineered timber is being used on that house and watch it all the way through. So that's one of our case studies. We've got others as well, including a retrofit. The Kimber story is nearly complete now. We've got our courses, we've got our live training sessions with guest experts, and we've got our office hours call where you can just have a chat with me. What's on your mind? I'll have a chat. We do that every week. So if you want to find out more, very simple, head to our website, houseplanninghelp.com/join. That's it for today. Thank you so much. The House Planning Help podcast is produced by Regen Media, content that matters.